Black holes, the enigmatic cosmic entities known for their insatiable appetite for stars, are now baffling astronomers with a perplexing behavior. It appears that up to half of the black holes that voraciously consume stars later expel remnants of these very stars, a phenomenon likened to a celestial burp. What makes this phenomenon even more intriguing is that it occurs years after the initial star-devouring event, leaving scientists perplexed as to the underlying cause. This astonishing revelation has come to light after years of painstaking observation of black holes engaged in tidal disruption events, TDEs. TDEs occur when stars venture too close to these gravitational monsters. The colossal gravitational forces exerted by black holes subject these stars to extreme tidal forces, causing them to undergo a process known as spaghettification. During this gruesome process, stars are stretched and compressed, akin to pasta being pulled apart. This stellar ordeal unfolds at an astonishing pace, with stars being ripped apart or unraveled in a matter of mere hours. This catastrophic event is typically signaled by a powerful flash of electromagnetic radiation, particularly visible light. Some of the stellar material from the hapless star is flung away from the black hole, while the rest coalesces into a thin, disc-shaped structure surrounding the black hole, known as an accretion disk. Over time, this accretion disk gradually funnels the stellar matter towards the voracious black hole. In its early stages, the accretion disk is inherently unstable, causing matter to slosh around and collide within it. These violent interactions result in outflows of energy and material, which are detectable through radio waves. However, conventional astronomical practice has typically focused on studying these star-consuming black holes for only a few months following a TDE. In this groundbreaking research, astronomers have extended their observations to span hundreds of days after TDEs, yielding astonishing findings. In up to 50% of the cases, black holes were found to burp back stellar material years after the initial star-devouring event. Yvette Senders, the lead author of the study and a research associate at the Harvard and Smithsonian Center for Astrophysics, likens this phenomenon to a celestial burp. She explains, if you look years later, a very, very large fraction of these black holes that don't have radio emission at these early times will actually suddenly turn on in radio waves. I call it a burp because we're having some sort of delay where this material is not coming out of the accretion disk until much later than people were anticipating. Intriguingly, the re-emission of stellar material in 10 of the 24 observed black holes occurred between 2 and 6 years after the initial star-devouring events. These remarkable observations have been documented in a study uploaded to the preprint database Arxiv on August 25th, although it has not yet undergone peer review. While the phenomenon itself is captivating, the underlying cause remains a mystery that continues to elude scientists. One thing is clear: whatever triggers this burping behavior does not originate from within the black holes themselves. Black holes are defined by their event horizon, a boundary beyond which gravity is so intense that even light cannot escape. Senders elaborates on the complexity of the situation, stating, "Black holes are very extreme gravitational environments even before you pass that event horizon, and that's what's really driving this. We don't fully understand if the material observed in radio waves is coming from the accretion disk or if it is being stored somewhere closer to the black hole. Black holes are definitely messy eaters, though." Part of the enigma stems from the computer models used to simulate TDEs. Traditionally, these models concluded shortly after the star's destruction, typically within weeks. The latest research indicates that these models need to be re-evaluated and updated to account for the unexpected and complex behavior exhibited by black holes. One particularly intriguing observation is that in 2 cases, the radio waves emitted by black holes experienced peaks, faded, and then peaked again. Senders explains, "There was a second peak, the 2 black holes re-brightened, and that's completely new and unexpected. People were thinking that you'd have one outflow, and then it's kind of done. So this observation means these black holes can turn on and then turn on again." As the quest to understand these mysterious celestial phenomena continues, Scientists are committed to closely monitoring all black holes involved in TDEs, especially as some of them continue to exhibit increasing brightness. The tantalizing mysteries of black holes persist, reminding us of the awe-inspiring complexity of the universe that surrounds us.